These two pumps will take the water from this tank. These two pumps will take the water from this tank. Each pump has separate control valve. If I want to be, this pump is only to be operated, I will switch off this valve. Otherwise, what will happen? It will take the water, half water go from this side, and rest of the water will go back into the tank. So because of that, we require two valves. So if I am operating only this pump, so I have to keep this pump closed. Or this one closed.
Pump 1, which is pump 2?
This is pump 1.
Okay.
This is pump 2. Okay.
You have to buy paint, right? All the things.
So when
Yes,
we
sir.
use it for,
When you operate it, you will
both, na?
No, it's better.
very
better.
easily distinguished. Yes, sir.
When we go for that higher flow rate, then we have to keep open for
Both.
Both. Yes.
At what level one can help? Like what is the maximum flow rate can be with only one single pump?
Approximately, I didn't see that. I think it's approximately 180.
180. Oh, okay.
Up to 180 metric cube. You can go. Maybe more than.
Which means our flow rate experiment is more than 180, then we'll open the boat.
Open the boat. Or you can do like that. You operate it at half speed. You operate this also at half speed.
To make it total which we require.
Yes, which we require. Or you can.
Right.
Okay.
I understand.
Then this is your delivery line. This is your delivery
This
line.
is the
इसके बारे में थोड़ा एक्सप्लेन कर दो.
this is the tank for
Sediment. For sediment. For sediment, you can see here there's a
this simply
wall. When I open this wall, all the sediment will get deposited here. It is a strainer, and rest of the water will be inside this tank.
Okay.
So later on you can remove that water and measure the sediment. Whatever it is deposited. Okay. So this is your delivery line. This is for controlling, fine controlling. It may be possible that you want exactly 55 metric cube per hour, but there you are getting either 50, either 54, and then it jumps to 57, 58. So what will you do?
okay.
Partially close this, and you can get exactly
Which is required.
which
So
is you want.
that whatever we are telling now, then the display will show us 55 if you have this.
Yes, surely it will show. Okay, so actually what happened is we never want, if suppose VFD is not there, we can control from here also. But what happened is when we are operating at the low flow rates, we have to close this to this one. Then there will be too much load on this pump.
Okay.
Okay, so pump should we generally wants that pump should be operated in fully conditioned so that it doesn't affect the efficiency or the working of the pumps. So that's why we use VFDs. Then for small flow rate,
Small changes we can do.
we
it.
can use this for very small changes. Okay, then we come straight, and then comes your measuring instrument, that is electromagnetic flowmeter.
You have covered this one, but all the LVDTs are exposed, no? All the LVDTs are tilting or used.
It is connected with the help of this.
with the
So it has the display also. You can
Here also.
find it here, and we can also find, but it will be very difficult when the person is operating from there.
Okay.
So the discharge which is you are finding here, the same discharge you will find on that screen. This is flow meter, and this flow meter works on the principle of electromagnetic operation. So that's why it's known as electromagnetic flow meter. Generally what happens is it has two electrodes like that. The electrode material is SS316, and when we give some current to that, it creates some magnetic field. And since we know that water is a very good conductor, so here water acts as a conductor, it cuts the magnetic field. And we know the basic principle that when there's a conductor moving and a magnetic field is static, and when they both cut each other, there's a voltage induced. Now as more as the conductor cuts the magnetic field, more is the voltage induced. So in that principle, this electromagnetic. So higher the velocity of the flow water, higher will be the voltage. So that voltage is been calibrated in terms of metric cube per hour. Okay. Then after that, with the help of this hose pipe, it goes into the inlet side. So this is your jacks. Each jack has a capacity of 5 ton.
5 ton.
One jack has a capacity of 5 ton. 5 ton, 5 ton, 5 ton, 5 ton. So
10 tons
simultaneously it has capacity of maybe point load is not more than the 5 ton. It's never going to be more than 5 ton. Okay. This is the spindle. These all are interconnected with the help of these gearboxes. And this gearbox has a ratio 1:1, then that has a ratio of another ratio, that has different ratio, that has different ratio. So it is like that, that if it lifts 300 mm, the last one will lift only 80 mm. So that's why we have created that tilting variance. So it can go both up and down to create the positive and the negative slope. And to determine the slope, we have given at the last one LVDT.
Okay.
And that is LVDT is calibrated in terms of degrees.
Okay.
So you will get the tilting in degrees, and you can see one instrument here also, that red one.
Yeah.
These are the limit switch.
Okay.
To avoid if someone go beyond the limit, that will cut the motor down, and you will find the cross here there. So you have seen that those two right click, and then if it is pressed, then it is crossed, then you will be realize that oh no, it's going above the limit. Just to avoid any accident. If accidentally someone goes on pressing some students, maybe mischievous, get
That
press.
That happens.
So it will not go beyond that. Okay, that's for the protection only.
What is this one? Left now? Side of this one, it's last.
Yes.
What is this one?
We have to clean.
In nanometers, it is 0.001 mm.
It has been calculated in degrees.
No, it will.
I have calculated in degrees.
He will give you output and degrees.
It is giving output to the screen in mm. Then there's some formula. Formulation. If accidentally gate is completely closed and you have switch on the pump, so there will be a chance that water will get spill out. And if you are here, it will be very difficult for you to get it run there and then stop the pump.
That's what its sensor is
So
there.
the sensor is there.
Okay, it will get automated switch.
If the water is get up to here, it will lift this and your pump will be automatically off, and it will not get on until you will go there and reset that.
Okay.
Okay. Okay, I will.
Or make it in the other side.
I will I'll make it.
Like this sort.
It's not visible. I think
These are manometer fibers. You can see these holes.
All the points are connected with that manometer. It will give you the pressure head, total head, na? Yes.
They can.
Yes, sir.
from 1
Yeah.
to n.
Yeah, maybe. The distance also maybe he may know. He can tell us. That
It is
manometer.
a manual. It is written in manual.
Manual.
Actually, as he said, we are suppose like the river bed, we are going to fill it with some sand for some time.
Yeah, I
நான் அதான் சொல்கிறேன் சோக் ஆயிரும் என்ன பண்ணான்னு கேட்டு
Oh.
இப்போ அந்த
ஆமாம்,
ரோல்ஸ்
ஆமாம்,
கொடுத்துருக்குது அது
ஆமாம்.
சொன்னாங்க இப்போ சோக் ஆயிடுச்சு என்ன பண்ணோம் மண்
Correct. அதில் ஏதாவது ஃபில்டர் ஏதாவது வச்சு ஃபிக்ஸ்
No, give me permanent solution. That's what I'm asking. I don't want temporary solution. Give me a permanent solution. Because still we are there, it's no issues. Someone fills, then doing everything becomes chaos. Give me some permanent solution.
Actually, it can be easily removed from the
that is
bottle.
fine. See,
Then it can be easily.
Sir, you are telling for us.
is it possible to kind of what is that? You have some screen, na?
Yes,
Screen.
definitely.
So you make it mesh, right?
Yes.
You make a circular small mesh.
सर फाइन
And then
सील्ड विल गो ना
गेजेस है मेरे पास वो भरने के लिए वो रेता घुस जाएगा ना ये क्या है इसके अंदर रेता घुस सकता है ना ये जो प्रेशर रेजिंग पॉइंट हाँ तो नीचे से खोल के आता मैं भी वही बता रहा था
नहीं तो उसका अंदर नहीं घुस जाता है वो पाइप का अंदर मानोमीटर के अंदर नहीं, अगर रेन के
You
टाइम
are,
में आप
you can
उसको install
disconnect.
करते हो
You can easily disconnect.
तो ओके
It's like a push system.
Yeah, I understand.
You can disconnect, and then it will not be any problem.
No, but when if I need that time measurement also, so what we can do?
No, with
no.
sand you cannot make the measurements also.
Why?
Or if you are making, then you have to use that what I was telling you. You have to use that mesh material and then fill it with that mesh material. Then sand will not escape. Only water will go there. Or if you are saying that, then I will do that. I will cut
make one
those
small,
in
and paste
yes,
it
yes,
there.
and then fill it there.
Fill it there so that it will be
Okay.
permanent there, right?
ये कि जब जरूरत हो तब उसको हटा दें।
Higher
नहीं, हटाने की जरूरत ही
हाँ।
नहीं पड़ेगी ना फिर। पानी तो उसमें से आराम से निकल ही जाएगा ना।
you make some glue or something so that permanently.
वे है वो जो मैश क्लॉथ है ना हमारे पास, उसको गोल काट के या थोड़ा सा काट के उसके अंदर भर देंगे।
नहीं, जरूरत नहीं होती, कोई भी दूसरा वो सिस्टम बिछा लो आप लोगों को, कोई भी कपड़ा डालो, दो तीन बिछा लो, वो मैच बिछा लो, कुछ भी उसको पर डाल दो, हो जाता है। अदरवाइज वो जब आपको वो सेडिमेंट का एक्सपेरिमेंट चल रहा होगा उस समय मैंने क्या करना है,
जरूरत नहीं पड़ेगी।
हाँ,
मैं इसलिए कह रहा हूँ कि ये
क्या
एक्चुअली एक्सपेरिमेंट में तो नहीं
सब
देखा।
तब में खोल के रखें, सो व्हेन वी डोंट रिक्वायर टू ओपन इट। हाँ, जब उसमें जरूरत नहीं है तो वो बंद हो जाता है, फिर जब आप उसको खोलेंगे वो निकल जाएगा उसके बीच में। फिर हम सेडिमेंट यूज பண்ணுறோம்னா मानोमीटर தான் पटा देंगे हम उसको।
Or you can use some any type of cloth,
धोती।
make a base of that and then put the sand. It will not create any problem.
But I feel that you just make.
Okay, to open it, close the. This will be operated like that. It's very easy. Not that much hard. And you can see this is the plate. This is to be opened like that only when you want to measure the sediment. Otherwise, you can close this by opening those balls. It will go down and it will be closed.
Then again you have to just put,
Or you can keep it like that.
okay.
It will not do any harm. So because the water is coming here. Or if you want to close it, there is a nut inside. You have to lose it and then it will go.
Okay, though again if I want
Go
to
down.
lift it, again I
You
have
can
to
lift it. Yes, you can lift as much as you can. Okay.
Like
यहाँ से
physically-
lift कर सकते हो.
Physically I will up down. It means
Yes, yes. Physically आपको अंदर घुसना पड़ेगा और
go inside and-
क्या complicated task है.
ये है ना हम
घुसो अंदर. इतनी बड़ी फ्लूम ली है तो काम तो करना पड़ेगा.
वहाँ पे घुसवा के
छोटा
छोड़ोगे।
सा लैडर जैसा बना के रख दीजिए उसको। इधर तो छोटा सा लैडर, तो हम लोग खुद जाके अंदर जाके तो फिर आना पड़ेगा ना। छोटा सा वही स्टील से
कोई स्टेज टाइप का कुछ बना दीजिएगा।
उस ऐसा
चाहे
हैंग
छोटा कुछ दे देंगे.
ऐसा हुक वाला, ठीक है हाँ, ऐसा हुक वाला, तो कहीं पे भी हम जाके इसको हैंगर करके अंदर कर ले सर क्या पड़ो नहीं।
Okay, so this was all the explanation. You can operate it for different experiments.
So can you run once with water?
So first we will start with running. I should
Switch on the pump first. Oh, make
ये
it
already
put
on.
it down.
Okay.
You can see the difference. If you see those moving things, that was moving very faster and this one is very slow. And you can see the tilting angle is changing.
चेंजिंग हाँ।
This angle will be theta. I mean degrees.
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 It's in degrees or radians? I think it's in radians.
It is in degrees.
0.382 degree.
Yeah. So degree is very less. 1 degree, 2 degree, 3 degrees in slope is very good. Generally slope is expressed in percentage. In specification it is 1% tilting, 2% tilting. But if you convert it into degrees, it is always in 0.5, 0.6, 1.2 degree, 1.3 degree. That was slope is enough for any experiment.
Everything is.
That because some water will be there inside the pipe. That is now moving.
क्या हो गया पूरा?
If I want to start the pump, I have to first of all switch on this.
Pump 1.
Before that, I have to make sure that all the right valves are opened or not, and then I will set some speed, say 20 hertz, 40%, and then the flow is ready, and I will wait.
Take a video of this water
Yes,
which is
sir.
coming. Water is coming. This is 30 centimeters, right?
Oh, discharge. Hertz. Oh, sorry. Motor.
What I operate is that maximum speed
50 hertz.
That is the maximum speed of pump 1.
ये दोनों पंप ऑन कर दिया, एक है, एक पंप ऑन किया, दोनों पंप ऑन किए अभी।
एक
Yes, ma'am. After a long time, na ma'am. After 1.5 years. This one? Ma'am, this is for wave generator. Yes, ma'am. Well, we can connect this one with this to generate wave.
This is for wave generation.
Yes, ma'am.
Good wave is coming.
if you want to see the procedure for first experiment, what is the flow, what is the hydraulic radius. For hydraulic radius you should know the wetted parameter
A by P.
A by P, and P is your wetted parameter, that is I think twice the width plus height.
Twice the height.
Plus 2 height. And then you can see what is the depth at different places, and then you can average it and formulate it, and you can find out the Manning's coefficient.
Equation is D equal to 1 by N
R की power 3 by 2,
S की power half.
1 by 2.
So we will get that N value.
Yes.
That N is nothing but the slope. The slope, how much we are thinking will give you.
Manometer come.
It's a manometer.
So we have to remove that trapped air like that.
Okay.
So you can directly do like that.
So we will allow the water first, then we will connect it. Okay.
Very useful, but okay. Even our water has some small dust.
Okay. This will anyway, while doing we have to release the air.
Might possible some particle is being there in the hole, so for that you have to check with the इनकी करने में निकाली थी these one I have to use. So it will be only your first time thing that you have to remove the air and then let all the water to be passed, and then you will see the
ஸ்லோக்கு பிரேக் பண்ணி போட்டு போடுங்க ஒரு அடிச்சுட்டு போயிடுச்சு ஸோ ஈஸியாக வந்துடுச்சு அந்த முடிவு
yeah, open it all and then clean it. So I will prefer that you will drain out this water and use fresh water without any chemical.
I think the best will come from this side. I think very difficult. This particular.
Yeah, it is more fresh anyway. It's more insect.
ये कैसे किया आपने, जरा ये बता देते।
Any position if you lock would not anything.
Yeah, see, if I get it stop without saying it, it will stop. Yeah. You want to increase the speed. Speed का कितना था? 160. ये देखते हैं 19.99 लिखा हुआ है।
So, using this now,
Yeah.
using this, what is the wave height we need to do? So the next thing I'm pulling it half. Full height, we cannot fill it.
So
Very
you have you never have to fill it above 1/3. Max you can fill above up to 1/3
Of this height.
of this height, and then the frequency should be low. If you're making it very fast, then try to make it at the half. But up to the half, you can go up to any speed.
Can you fill it and do one such
First condition.
worst condition? Lab experience.
One more thing. That can never be determined when if you increase its space too much height and there is a collision of the waves, then it will be a tidal wave.
Yeah, I understand. No, for that only I'm asking, what should be the height? It should not spill out, nah?
Yes.
But இங்க கொஞ்சம் லீக்கேஜ் ஆயிட்டே இருக்கு.
இல்லை சார் இப்போ நெட்டி
இல்ல அந்த சைடு லாக் பண்ணிடுறாங்க. ஹைட் will be same.
அப்ப இத பூட்டணும்.
This is an example of hydraulic jump boring.
Oh. This is hydraulic jump.
Where the locking system is there. Fully welded now. We are doing dot welding. This piece is there. This piece is welded with this welding. So there.
Through that leakage may be there. Okay.
Inside. This
Yes.
this base. This one is okay. This is not subject to any water. Huh? This one is okay for this and that. If you pour it full well, it will be better. I think.
Maybe we can arrest the leakage.
Generally need some drop-wise leakage because if you make it completely blocked, it will be hard to open.
No, I'm not asking you to
You are
block
saying about this.
this for this attachment. Some leakage will be there through this. Then for that, if you want, we can use indispensable or something to arrest. That is different.
When you bags or some plastic bags, you keep and if you not something
That is okay. Not in all the places. Wherever the manometer is connected, no, that it should be in reverse. What you have done should be in reverse.
Okay. मैं भेज दूँगा. बहुत पड़ेगी.
We are giving simple solutions. We are giving simple solutions. Otherwise, the other way is put a small hole here, put in nanometer. That is not complicated thing. Manually, anyhow it has to be done manually.
Okay.
Some leakage. Rahul sir, you have to give us an idea how to arrest entire thing when you do it. Because now it's okay. If you can operate this one, then we'll discuss this.
Type of standing there only.
This is wave generator. So now we are generating waves.
You see, he is not increasing at a single time. He is slowly increasing.
Yes, sir.
You also do it for some time. You also do it for.
See, this is what.
Yeah, thanks.
That is quite simple.
Now we are making auto level down. Now frequency 25.
You can increase to 95%.
Now it is 60%.
Now it's 30%. No, आदत तो मिले नहीं क्या
I will increase the speed.
so just go.
Now how much? 70%.
Now frequency is 70%. Now frequency is 70% at this, and they increased.
Make it level down.
कितना परसेंट बता रहे हो आप?
60% डबल करते रहो।
अच्छा, इसमें अगर यहाँ पे फ्रीक्वेंसी दिखा रहा है 30%, मीन्स के इसका डबल हो जाएगा 60%। 40 पर करते हैं तो इसका हो जाएगा 80%। 50 पे करते हैं तो इसका हो जाएगा 100% फ्रीक्वेंसी। फ्रीक्वेंसी जो अभी यहाँ पे दिखा रहा है 30%, 30 पे किया हुआ तो इस मीन्स का इसका डबल करेंगे हम। अभी है हुआ 60% इसका फ्रीक्वेंसी है। जब 40 पे क्लिक करेंगे तो हो जाएगा इसका 80%। 50 पे करेंगे फिर हो जाएगा इसका 100% फ्रीक्वेंसी फॉर वेव जनरेटर।
ಇಲ್ಲ ಅದನ್ನು போயிட்டு ಅದನ್ನ நிறைய போயிட்டு பாருங்க
இல்ல அது வேற மாதிரி. Another thing will be from bottom, too much of water will be moving.
ಸೈಡ್ ಲರ್ನಿಂಗ್
For your time, Albert, I will apply some silicone gel.
No, first you provide full gel. Silicone gel, the life of silicone gel is only 1 year. That's under this condition. I cannot again go and keep on applying silicone gel because it has to be properly removed and then you have to
Why
apply.
we have not applied the full welding? If you apply the full welding, the shape of this will get changed, and
No.
then it will affect the movement of this.
No,
now it's fixed, now you can pull it.
with this condition you will nothing will
Nothing
happen.
will happen.
I will tell you. Nothing will happen.
How it will happen? It's fixed already. For that only it's already surface fully there, no?
So when you are going to welding this, it will get heated.
Yeah.
And when it will get heated, it is going to change its shape a little bit. And 1 mm in deformation also will tighten this. And then it will be too much hard.
No, it is a 16 mm, no? 20 mm it will be found.
Yeah.
Nothing will happen.
Strength is the main motive or leakage?